first of all, I want to say hello. We at Deutsche Telekom are especially interested in several types of disaggregation. And one of our key projects to move that ahead is actually what we're doing in the Access 4.0 project, where we're looking at fixed access disaggregation. And as such, I think me being the head of development here and also being the person responsible for the operations once we have it rolled out I hope I can give you some insights into what we are doing. But in order to prepare that, I would also like to go through some points of where opportunities for disaggregation are. Okay. So with that, let me get going. Let me move my inputs to the right screen so that I can actually do something. Okay. So first of all, why are we embarking on that journey, and what are we doing, or what's the reason that is taking us here? And these are kind of those challenges that we identified, at least for us, as the key challenges in fixed access overall. Annie, I see you have a question. Do you want to directly interrupt me, or?
No, please continue.
Okay, just I saw you raised your hand, and thought that was okay.
It was an accident.
Good. Okay, no worries. Perfect. So there are several things. The first of all, and I think this is not a new one to you all, is that typically what we end up a lot as telecommunication operators is that we're ending up in a vendor lock. And in fixed access, especially at Deutsche Telekom in Germany, we are in that situation that we have now a good solution that has been in operations for several years. It is a monolithic solution, so it's a single vendor that is providing hardware and software all in one box, a big chassis, multi-line card system. And there has been, over the years, feature over feature that has been added also upon our request, of course. But now we are really in a situation that we are at the limits of what the system can do, and adding yet further systems or further features and products to the overall thing becomes so cumbersome, and is such a fine-tuning of available resources in the system that all future extensions, so to speak, become very complex, and that's not only a problem of having a single vendor that we're working with here, but it also is due to the fact that the overall system was designed in that way that it is, and that also now actually puts us in the situation that adding new features does take time. It does take years in our case, and when we are basically needing to extend our deployment, our rollout, we are kind of bound to that one solution that we have, and therefore we are also not very flexible in terms of what we put there and how we can do the pricing for that. And overall, and actually that's also one of the problems that we run into with our project, given that currently all the network was so much focused and centered on that one architecture or that one solution. Now moving away from it basically means for whatever we want to touch, we need to pull out everything of that old system and swap it over to something new. And that was the main driver why we started the overall Access 4.0 project, which also has had as a background not only the idea of separating and doing disaggregation, but it also came from the fact that, look, we're trying to move more into a software-driven architecture. We're trying to become more of a software telco ourselves. So it's picking up several points, but disaggregation was one of the main drivers, actually. So now, when we're talking about disaggregation, I want to make sure that we're kind of having a similar understanding. And I do see two big types of different types of disaggregation, and people keep sometimes mixing and matching those, while in my view they can be considered as separate things, and this is also something important when we're talking about that. So the first type of disaggregation is that we're separating hardware and software. And now I'm talking just a single box. In the past, basically, when we looked at network elements, it was typically a single vendor solution. You go to Cisco, you get your box, your hardware, your ASIC, your switching chip, your routing engines, and so on. You get this hardware, and you get it bundled together with the operating system, with the kind of GUI, with the control plane implementation, with a little bit of a management stack as well. So you get that bundled. And one type of disaggregation is that you're breaking that up. You're sourcing your software, operating system, the virtual network functions that runs on top of that. You get that independent from the hardware itself. And actually, that's not too different from what the large incumbent vendors in our industry are doing themselves. Cisco, for most of the parts, is not necessarily manufacturing their boxes themselves. They also have them manufactured by one of the large OEMs from the Asia region. And then they already have a deal with them that they already put the Cisco software on top. So basically, what we try to do is here, when we're talking about separation of hardware and software, is that we do the same thing, but we basically start using multiple sourcing channels for the hardware versus the software, and therefore hopefully get a better price. Now, overall, this only helps, of course, if you want to go down that route, and if you are large enough that it makes sense for your company, or if you're big enough as an operator to actually entertain these different sourcing streams, which I understand is not necessarily always the case. But if we basically build the system in a way that it is distributed and disaggregated, you at least have the option to do so. The second type of disaggregation that a lot of people are talking about is basically separation of control and user plane. And now we're talking about something different. There, typically, you're talking about having a network element, the user plane, which kind of has the hardware. It might be even already a disaggregated hardware-software box, right? In this right picture, the user plane, this might be one complete box from over here. But here, for the control and user plane separation, the trick is that you then also take the decision making, like the what to do with the traffic that you're working with, or what to do with the subscriber traffic, which policies to apply. You move that control and the mechanism on how you probably also want to combine the functionalities across multiple network elements. You move that out of the network element itself and put it into an SDN orchestrator or management system. Now, when we're looking at where in the network we can think about doing some disaggregation, and here I'm focusing on the fixed access. I would have really liked, I did spend a little bit of time yesterday to search for a nice picture that is having a unified architecture of how an access network looks like. I unfortunately didn't find something, so I quickly improvised something here myself. So what I've drawn here is that we have multiple kind of regions or tasks that we have within the fixed access, going all the way from customer premise, then going across the access nodes, which are doing the last mile termination of the cables, then going through an aggregation phase where you're trying to combine the small bandwidth links into higher ones. Then you feed into the service termination, and this is basically the main core typically of fixed access. This is where the services are formed, where the QoS is applied, where the forwarding is determined, where the traffic handling is enforced, and then you go into the backbone. Now, all of these boxes that I've drawn here, I think, are in principle candidates for disaggregation themselves in multiple ways. At least for the hardware-software disaggregation, probably also a little bit. And the further to the right you go, the more you have that. Also for the control and user plane separation. Now, what we're seeing here in terms of customer premises, you have the typical stuff. You have your routers, your CPEs, your remote devices when you're talking direct Ethernet, or in the context of PON, sometimes you have your router split and separated from the ONU. So the ONU is the fiber modem, so to speak, if you want. Typically for copper, you have those combined, but of course you might also have a modem here separated from a router. So these are all boxes that might be subject to disaggregation. Now coming to the access nodes, it gets further, and actually there was also a lot of industry movement on those. Looking at the OLTs, which are the access network, kind of on the operator side, devices terminating the PON trees. You have DPUs, which are units that you would attach to an FTTP type of setting within the building, and then to that you would attach the routers. You have the multi-service access nodes for copper. Typically, when we're talking direct Ethernet, you don't have anything in terms of access node here. You would then directly go into the aggregation and service termination. On the aggregation level, you have simple aggregation switches, which only have the purpose of combining multiple low bandwidth ports to higher bandwidth ports. You might have something like a fabric if you are in an edge cloud situation where you also want to have some cloud and compute and storage potentially closer to the edge. And then you're going into service termination where you have a whole range of functionality. Typically, you would have something that is doing the same as a BNG. You would have bitstream access on layer 2 and layer 3 levels. So hand-off points to wholesale partners here. You would probably also have support for EVPN and some other business services. And then you end up with a label edge routing functionality towards the backbone. Now, if you're looking at what we are doing, trying to do at Deutsche Telekom, I kind of colored a little bit the interfaces or the boxes here that are in focus for our project, so the main thing, basically, what you can see here is in the middle, where we have the aggregation and the service termination, where we are looking for a fully disaggregated stack. And with fully disaggregated, I basically mean both the hardware and software, as well as user plane and control plane. But we are also looking to a certain degree into what is happening on the access nodes in the case of the passive optical networks. So in the FTTHB deployments, where we're looking at doing at least a control and user plane split for the OLTs and the DPUs. And as such, what we're using for the OLTs here is actually an open source project. You might have heard of Volta, VOLTHA. So that's a virtual OLT hardware abstraction. And that's an open source project that is run by the ONF, the Open Networking Foundation, which allows us to basically, as long as an OLT is supporting the driver of Volta, you can plug in whatever OLT you like. And that is one abstraction layer. It's also disaggregating a little bit within the control plane, so to speak. And then we're moving on here. So now coming a little bit more into the direction, what exactly are we doing at Deutsche Telekom in the Access 4.0 project? And one big chance to have learned about that was actually this year at MWC, where we had a little bit of a stand. And here on the right side, on the left side, sorry, in the picture, you can see our, show box, if you want. We had a little video running in the background. That was, of course, this is not the how the real hardware is looking like, but it should give you some ideas on where we are. So kind of Access 4.0 in a nutshell, what are we doing? So we have this current situation, and I'll start here on the left. We have this current situation where we have our fixed monolithic BNG, which is hardware and software combined, everything from one vendor, that is hanging off of our backbone, and that is terminating several types of access, FTTH, B, C, and business, basically. And we want to move that over into what is shown here in the on the right side of this box, which is a flexible, extensible architecture, which is based on white box hardware, which has open interfaces, which has APIs that can be used, and which is then building on software that is also organized in a kind of microservice fashion. Therefore, again, we're terminating the same access, but we're doing it a little bit different. We're building up our little own cloud-like architecture here. We termed it leaf and spine. I know it's not the typical one because we have the core hanging off of the spines. If you are a data center architect, you would never do such a thing. You would always have your spines only connect to leaves and hang everything else off of the leaves. However, in our situation as an operator where you have most of the time north-west traffic rather than east-west traffic that you see in the data center, it does make sense to actually attach the core to the spines in our case. And what we're also doing is we're not only putting networking hardware in here, we are also adding x86, so some compute. And yes, we labeled it Edge Cloud here, although right now the purpose really, and I think for now what we are all happy with is that we say these x86 or these standard compute resources we will use in order to run our control plane and management plane software for the whole pod. But this is also the place basically where we do the abstraction towards our management systems. So the big new thing, or the rather special thing for such an approach, you might have heard of the CORD initiative, for example, Central Office Re-architected as a Data Center. There you would find something similar where you also have kind of a fabric in the middle, you have x86, but in those cases, typically what you find is that you have your service termination happening on the x86 hardware. In our case, we made a cost analysis, and we are still convinced that even right now, it is much more cost efficient to do service termination, like the pickup of the kind of traffic that comes out of your home router and turns it into IP for the networking, that this functionality is much better situated on an ASIC. And this is why we are kind of overloading a little bit the functionalities of our fabric components. So the leaves have the job to terminate actually the customers, to turn the PPP into IP, and that basically applies the QoS and ACLs and whatnot to build up the service for the customer. And then in the spines, basically, we also put the label edge routing functionality towards the core. And now, if you recall what we had in the picture before, this is kind of where we then implement all of our virtual BNG functionality along with the LER. And out of I just realized that I also use the same color scheme a little bit here, because for the OLTs, which would be the FTTH and B, we would go with the partial disaggregation. I feel like we likely talked about most of the benefits. I'll quickly go through them. So with that approach, and given that we're also building our own software here, we get into the situation that we kind of can try and play around with the system, that we can run POCs on our own. We don't need all the vendors on board all the time. So we get into the situation that we can innovate much faster, that we can try things out, that we can just change it and deploy it as we go. That basically brings us also shorter time to market for some of the ideas. And it also allows us to potentially work with more partners that we have today, because we can just scope the overall change in much smaller packages and then send them out to multiple places. Of course, that requires coordination, but yeah. Network quality, we do add much more redundancy due to the fact that we can if one BNG dies, everything that is attached to it dies. In our case, of course, at second stage, at a later stage in the project, we also intend to dual home our access nodes onto multiple leaves. So in that situation, we would then get much more redundancy. Once we are at the leaf level, everything is redundant anyway. So we are also, at least in our situation, what we are seeing is a big savings potential, both on CapEx as well as an OpEx. It is, of course, always challenging if you are situated in a brownfield deployment case, which is for us the situation. So there you need to then carefully look into how do you do the migration, when do you switch the one system off, move to the other, and so on and so forth. So there are challenges, of course, but in a greenfield deployment, we're seeing huge saving potentials, which in the end also were the kind of deciding factor then to move over to that architecture. And basically, due to the fact that everything is, already modular, flexible, and put together, we do have also the much easier situation that we are looking towards a real multi-vendor situation, second and third, and you can really pick and choose kind of on a case-by-case basis also how you want to put together your system. We also, due to the fact that we do have an SDN control plane here that is, intercepting once the customers are connecting, we have the power also to steer that customer then to whatever terminating instance would be best. And that would then also in the future allow us to bring in probably dedicated service edges that are terminating only a subset of the customers as compared to what we have today, where we're terminating everything, all of our customers on the leaves. We might in the future also just, forward the traffic to a dedicated point thing that we attach to that fabric and terminate the customers there. So this is really the thing that enables us to look into a multi-vendor scenario. Now, in terms of what we're doing in separation of control or disaggregation, here I just copied in the thing. I think I talked about most of that already. Just want to re-emphasize, we do have CAPS, control and user plane separation. We do have separation of hardware and software in most parts. We do on a software level also do some sort of disaggregation, basically going for rather microservice based architecture than big monolithic software pieces. We use also new cloud ways of deploying software. So basically these x86 servers are forming a Kubernetes cluster on which our control plane and management plane components are then brought up as Kubernetes workloads in containers. That way they can also scale and grow as need be. Currently, we're not looking into potentially switching off servers, but that could be an extension for the future. So there is also potential to innovate, basically going forward. And really, the main purpose that we had in mind when we were building and designing the system is that we want to design it for change. So we know that change is coming. We know at some point in time our hardware will change. We know that at some point in time more things can be done on an x86 basis, for example. And we try to build a system that is ready for it by adding several layers for abstraction, one within the devices, one basically on the towards a common control plane. Then we also abstract the whole pod. So one of these CO locations, these we call them pods, points of delivery. We will also abstract those towards our core or central management systems, and by doing so, we really are building for future change. A quick overview. I'm currently looking on the clock. I think I probably need to hurry up a bit. I just wanted to flash that, and I will not go into the details. Next slide is my last, by the way. This is picking up a little bit on a similar drawing as we had before, and you might recognize some of the terms here. This is now more showing the view that we do in the Access 4.0 project, which is basically having our pod here in this in this right area, where we again have the fabrics that you can probably recognize. The green boxes are the OLTs, the PON, passive optical network termination nodes. We are also bringing in the copper and the direct business access via aggregation switches into the same fabric. And then we basically have the virtual BNG functionality split into service termination over here on the leaves and the LER on the right. And then, as we talked about it, we have the x86 service, which runs control and local management pieces. And these then basically connect all the way to our central management system, which is then interfacing with OSS and BSS. Good. So to wrap up, basically, and I hope I didn't go too much into a Access 4.0 trade show mode, but I mean it's so close to the topic of the session that it I think really is fitting, and that is allowing to kind of really emphasize the benefits and the opportunities that we have with disaggregation. So today, basically, what we have is we do have a rather complex access network that is all fitting into a single black box, which is doing everything, and then connecting that to the core. Now we have basically 2,000, I think it's a little bit more than 2,200 already, of these black boxes across the 900 central office locations that we have in Germany. Tomorrow, so once we have migrated towards Access 4.0, we will build up exactly one pod at each location. So we'll end up with 900 pods. Each of those pods is scalable. We can add and remove basically leaves as we see fit, and thereby scale to a smaller or larger amounts of customers that are present at each of the locations. And it's basically all feeding out of a continuous development chain where we can implement and deploy changes in really short time cycles. Again, the whole thing is built for in a scalable and extensible architecture, and this is really where we're also leveraging the benefit of disaggregation for hardware and software. Because if at some point in time we find a better source for our white box switches, we just buy them. We can keep everything else, and we just need to make sure that the software runs on these new switches. And once we have that, everything else also doesn't need any change. If we need a new functionality in the software, we can just implement it. And this is where basically we are trying to go there. In terms of control plane, we run our software-defined network on the Kubernetes containers. on the kind of local edge cloud, and I'll put edge cloud in brackets. We're not currently looking into making that available to third parties. Right now, it's a operator only edge cloud, so to speak. And then for the user plane, we're putting the VPNG functionality on the white box switches themselves on the ASICs, which basically then also second as a fabric. With that, I would go into the Q&A part, and I already see one question from the audience, which reads, for the data plane switches within A4 architecture, is P4 or similar used to program the fabric? That's a good question. I would love to say, yes, we use P4. Right now, we don't. So we started when 2 years ago when we started, we also looked into P4 and explicitly also the barefoot switches. We run a little bit into the situation and the problem that the P4 capable hardware at the time, and I think that's still true, is not necessarily designed for the case of supporting several thousands of subscribers, which each have multiple services, therefore requiring several queues per customer. That was just not the design target of the hardware, of the P4 hardware. And this is why currently we are working on Broadcom hardware, basically. The new all the DNX stream of ASICs, because they are in better support, let me put it that way, of several thousands of subscribers with complex requirements towards accounting and queuing and hierarchical QoS. We haven't fully dropped the idea of leveraging P4 programmable switches, although I have to say given that our use case is not varying too much on the kind of hardware level itself, or on how the pipeline needs to be programmed in the switch, it seems questionable if we at some point in time really get into the situation that we can do that. So what we do right now is we basically build on Broadcom hardware. We are working together with a software supplier for the software on the box called RTBrick. And as part of that software, we do get a lot of control already in a kind of SDN-like manner on how what to do with the traffic. We are, however, still a little bit, use case driven in that regard. So we don't have the same flexibility that we would have with a P4 solution. But in principle, we are not fully discarding the idea. It's just currently there's no kind of good match in terms of hardware availability for us that it's really helping.
Fabian, thank you very much. That was great, because I've wanted to know more about Access 4.0 for some time. I now could maybe pass myself off as an expert if I can absorb all of it. Anyway, that was really good. It's really interesting, and I think so many issues in there that so many people, in operators are interested in. So thank you very much indeed. Delighted you could join us.
It was a pleasure.